Hello friends, this video on aldehyde ketones carboxylic acid part 18 is brought to you by exampeer.com. No more fear from exam. Now we'll talk about the acidity of alpha hydrogen. It has been seen that the alpha hydrogen which is there in aldehydes or ketones, they are acidic. And they are acidic because of the strong electron withdrawing effect of carbonyl group and also the resonance stabilization of the conjugate base. For example, if you see, this is my ketone or aldehyde. So this hydrogen is my alpha hydrogen. Correct? And this is acidic. Why? See, this goes off, this becomes slightly negative, this becomes slightly positive. Right? Since this becomes slightly positive, this has a better chance to leave. Correct? That is one. Also, if you see, if you remove this, it is more resonance stabilized. So let's suppose H plus is gone from here. So what you get is C minus, right? And now if you see, the C minus will be resonance stabilized. This bond will go here. Negative charge, positive, positive, and positive will form a bond. Right. So if you see, this is a stable compound. So the output which you get once the hydrogen is removed, this alpha hydrogen is removed, you see a stable compound. And thus, because of resonance, it adds to the effect, and this hydrogen leaves easily. So this alpha hydrogen is acidic. You see, that's why the term says acidity of the alpha hydrogen in aldehydes and ketones. The other I told was electron withdrawing effect of carbonyl group. So if I have my carbonyl group here, this whole carbonyl group as such has electron withdrawing effect. Since it withdraws electron, this develops slightly positive charge on this carbon. So since this carbon has slightly positive charge, this is easy to go off. It's easy to go off as H plus. Correct? Since the carbonyl group has electron withdrawing effect. Since this carbonyl group withdraws electron from this carbon, this is alpha carbon, the alpha carbon develops slightly positive charge, and with that, it is easy to push out this hydrogen. So because of two effects, one is this is the resonance effect, and this is the I effect of electron withdrawing group, that is carbonyl group. This alpha hydrogen or alpha carbon can easily leave its hydrogen, and that's why the alpha hydrogen is acidic in nature. Now we'll talk about aldol condensation. So this is in continuation with the alpha hydrogen which we have discussed, and thus for aldol condensation, at least one alpha hydrogen should exist. I'll explain this again when I explain the aldol condition. So this is the reaction between two molecules of aldehydes or ketone. So you can have aldehydes react with aldehydes, aldehyde reacts with ketone, or ketone reacts with ketones, right? So you have to take two molecules of aldehydes or ketone, and one of them at least should have one alpha hydrogen, and you to react in the presence of a base. Base can be KOH, NaOH, any of the base take, right? So the name aldol is aldehyde. I'll say aldol. ALD stands for aldehyde, and OL stands for alcohol. Correct? So this is aldol condensation, because the product you get is alcohol, right? And you get from aldehyde. Generally you get from ketones also, but earlier I think it was from aldehydes only. Even I'm not sure, but aldol condensation is aldehyde plus alcohol. That means you have aldehydes, from that you are preparing alcohol. Alcohol is the output and aldehyde is the input. But typically you see aldehyde is not the only input, ketone can also be input here. correct? And as I told, in the input you take aldehydes or ketone, it should have at least one alpha hydrogen. Okay, so we'll see one example of this condensation. Let's take aldehyde only. This is my aldehyde and this is also my aldehyde. Let's see the alpha hydrogen. So this is my carbon with carbonyl group. This is my alpha hydrogen and this is my alpha hydrogen. So it has alpha hydrogen, right? This alpha carbon has hydrogen, so it has alpha hydrogen. That means it is qualifying for aldol condensation. We do in the presence of a base, right? So the output we get here is alcohol first. Let's see the reaction mechanism first. As I already told, this is a base and base is looking for a H plus. And as I already told, the alpha hydrogen is the one which is acidic. So it will attack any of the alpha hydrogen, correct? So what let me do is put all the hydrogens like this. So it will attack any other alpha hydrogen. So let's assume that it attacks this alpha hydrogen, correct? Why? Because it is acidic, correct? So with this, what will happen is it will attack this alpha hydrogen and it will take out this alpha hydrogen. So what will happen is this will develop a negative charge, correct? So what will happen is we'll have this CHH with a negative charge COH. And the other compound we have is, now we are taking both same, we have taken both as ethanol. Now if you see this carbon, if you see oxygen is slightly more electronegated, it will have slightly negative charge, carbon will develop slightly positive charge. So this is now with a negative charge, this is nothing but a electronucleophile actually, right? This nucleophile will attack this carbon, correct? So what will happen now is, so I have this CH3, CO minus NH, and here I'll get C with 2 hydrogen and 1 COH. This is what I'll get. And there's a O minus, there are plenty of H plus here, because if you see 1 H plus came out here only, so 1 H plus will come and attach here. So it hit this, so what you get is CH3COH. So if you see, what you get is alcohol, correct? And we call this ketone. So ketone, there is alcohol, we call this as ketone. And this is an equilibrium reaction actually. If you see, the whole reaction is the equilibrium reaction. Now if you heat it further, what will happen is water molecule will come out. OH from here and H from here, it will form a double bond. So 1 H from here, 1 OH from here, it will form a double bond. That is only if you heat it. And with this, what you get is ketone. So this is the typical reaction mechanism for aldol condensation, right? So here for aldol condensation, we'll take same compound twice. If you want different compound, one, let's suppose aldehyde, one ketone, you go for cross aldol condensation. We'll talk about that. For aldol condensation, we take the same, maybe here I took aldehydes, I can take ketone also. The only condition is that ketone should have alpha hydrogen, right? I can take a ketone and I can do a aldol condensation. Similar way. So this was a aldehyde and it formed alcohol. This was the product. Only when you heated it, you get this ketone back, but this is what the product is for aldol condensation, right? Aldol, aldehyde to alcohol. Hope this is clear. You have aldehyde with the alpha hydrogen, and it happened with the presence of base. The first thing happened is base grab this hydrogen, the alpha hydrogen, because it is acidic in nature. We have discussed that. Carbon with a negative charge is my good nucleophile. I am confusing. Yeah, it's called nucleophile. Attack this carbon because this carbon has a positive charge, slight positive charge, because oxygen has slight negative charge, more electronegative. With that, you get this, and then this O minus, it grabs one H plus from the system, it becomes OH. And we can do this for any aldehyde or ketone with the alpha hydrogen. Why alpha hydrogen? Because there is no alpha hydrogen. This OH minus will not be able to pull out that. Because this is the first thing, this alpha hydrogen is the first thing that goes off and carbon forms a negative charge, that is the nucleophile is formed. The next is cross aldol condensation. So instead of single aldehyde or ketones, when the aldol condensation is carried out by two different aldehydes or ketone, it is called cross aldol condensation. Here also it happens in the presence of a base, and here also alpha hydrogen is first. Same thing, the only difference is it happens between two different aldehydes or two different ketones. But if you see here, it gives mixture of 4 products. Why? Because let's suppose I have aldehyde and ketone, right? So now this aldehyde, alpha hydrogen can go from here and react with the same aldehyde, one product. Alpha hydrogen can go from here, react with the same guy, one product. Alpha hydrogen go from here, react with this, one product. Alpha hydrogen go from here, react with this, one product. So 4 products at the max if both have alpha hydrogen. If only one has alpha hydrogen, then you get 2 product. Correct? Let's suppose this has alpha hydrogen. So alpha hydrogen goes from here, it react with this only, you get 1 product. Alpha hydrogen goes from here, it react with this, you get 1 product, 2 product totally. But since if it has alpha hydrogen in both this compound, then you get 4 products. Hope you understand what I'm trying to say. So let's see this reaction. For example, I have CH3 COH plus CH3 CH2 COH. Now if you see, alpha hydrogen is there, alpha hydrogen is there, both has alpha hydrogen. So it will give you 4 different products. 4 different products actually. How? See, first assume that the OH minus will attack this particular compound, right? This ketone, this aldehyde, ethanol. Now, if it attacks this aldehyde, the first thing it will form is CH2 minus COH. Correct? And now this can react with any of these. If this reacts with CH3 COH, it will form something. If this reacts with CH3 CH2 COH, it will form another compound. So I'll show you these 2 different compounds. Correct? So if you see, if this is the case, it will form CH3 C, this becomes O minus, right? O minus and H, and here this comes CH2 COOH, and it will grab one H. This is the output in this case. In this case, let's see this. Again, this will go like this. So we'll have CH3 CH2 C O minus and OH. Correct? Now this plus, it will grab this CH2 COH, and this O minus will grab one hydrogen somewhere. So this is the product will form. Now there are 2 different products. The second case is the OH minus. The second case is OH minus will grab this alpha hydrogen. So in that case, what you get is CH3 CH minus COOH. Correct? Now this can also react with 2 different compounds. One is it will react with this CH3 COH ethanol, and this is CH3, CH2, COH, that is propanol. So let's see the output. If it reacts with this, again negative charge, positive charge, and this positive charge, this will attack. So let's see what the output will be. O minus H, and on this positive, this will come. See, one has H here, one has CH3, and another has COH, and it will get MH plus somewhere. And in this case, let's see, again like this, negative charge and positive charge, so it will be CH3, CH2, CO minus H. Now in this positive charge here, right, it will get this carbon. This carbon has one hydrogen, one CH3, and one COH, and we'll get one hydrogen somewhere. So if you see, all these four are four different products. All are different actually. Correct? So if you see, if we are that if you use two different aldehydes or two different ketones and both has alpha hydrogen, you'll get four different products. Right? So if only one of these had alpha hydrogen, then you'll get only two different products. You will not get this set. You get only one set, that is two different products. So if both has both has alpha hydrogen each, both the products both the reactant which we are using, then you will get four different products. And this is my cross aldol condensation. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attend free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.